Well, hello. Good morning, everyone. As you heard, my name is Mahesha Manjunath Pujari, and welcome to the GAN program. We're going to hear about the topic Next Generation Sustainable Alternative Proteins for Food Fundamentals and Technological Innovations. And today we're going to hear more about some fundamentals of alternative proteins, what kind of sources we have, what types of alternative proteins we have, and why we need to have this alternative proteins in our menu. What is the importance and what kind of matrices can be used to get alternative proteins, what kind of technological innovations we have, and those fundamental aspects I'll try to cover today. I'm an Indian, so I was born in Karnataka, and I had my education until my master's in Karnataka. I come from NIT Karnataka, what we call NITK, Surathkal, where I did my master's in chemistry, and I myself call as a chemist with a specialization in food chemistry. And after my master's, I worked as a lecturer in chemistry for 2 years. And at that time, I realized that, okay, it's important to have a PhD. I had the urge for doing research in my heart. And then I thought to go abroad because I wanted to get some international research experience. And then I applied around the world, and I got into University of Camerino, Italy, where I did my PhD in chemical sciences for about 3 years, mainly focusing on food chemistry and food technology. And then I was awarded my first postdoc at the University of Copenhagen, Denmark, and I did not leave Denmark. And I was a tenure track assistant professor, and then I became an associate professor. Now I'm an associate professor on a professor promotion program. This is about my education, and this is about my experience as a scientist. I also traveled across different countries. I was working as a guest student at CDFT, Center for DNA Fingerprinting and Diagnostics in Hyderabad. I was also in Germany. I was also in Australia for research programs and so on. And as a research expertise, as I said, I'm a food chemist, and I really love doing research in the chemical aspects of foods. That means, okay, we have proteins, we extract proteins. Can we modify the proteins to improve their techno-functional properties? Can we modify the proteins so that when you eat these proteins, they are more and more digestible in your stomach? Okay, now they're digested in your stomach. Where do they go and stay in your body? Will they modify before going to your body? Will they accumulate in certain types of tissues in your body? And those are my research interests. I'm also leading one of the fantastic groups, I would say, and with a lot of PhDs and postdocs and master students, and they're working in different areas, mainly in food chemistry and technology area. I don't want to introduce them here, but I would like to say that my research group in Denmark at the University of Copenhagen is very international. We have students from Iran, Germany, Turkey, Thailand, and so on. So I really invite you guys to come and join my research group, provided you have if you get into a PhD program or a postdoc program or a research exchange program and so on. There's a lot of opportunities. I must tell a little bit about my university, University of Copenhagen, Denmark, and you can see Denmark is over here. Can you see? University of Copenhagen is one of the world's oldest universities, I think established back in 1479, largest university in Scandinavia, and we have about 37,000 students. And we have 10 Nobel laureates affiliated to our university. The latest one was Professor Morten Meldal, who got Nobel Prize 2 years ago in chemistry for discovering so-called click chemistry. You must have read it in the news. So we are also ranked very high in the world. It's #1 university in Denmark according to ranking databases, and we are always within 100 ranking according to some of the ranking bodies. For example, this Shanghai ranking and so on. It's also very diverse in the sense we have faculties like science, humanities, law, and so on. It's a really good university to study and do research in fundamental subject. In science, we do mostly fundamental sciences like life sciences, chemistry, physics, mathematics, astronomy, and so on. Then I must tell a little bit about my department. We call ourselves as Department of Food Science, which is divided into 4 different sections. But I would like to highlight some of the research areas we are doing at the department. Historically, we worked a lot in the area called dairy. So we have a lot of big dairy industries in Denmark, and because of that, perhaps our department has done quite a lot of work in dairy area. and also in the meat area, because Denmark is also one of the largest producers of pig meat, what we call pork. So we did quite a lot of work on meat and so on. But today, because of this transition from animal-based to plant-based foods, I can tell you that over 90% of our researchers in the department are working on plant-based foods. We're also really good at analytical chemistry, food analysis, chemometrics, and so on. And another key aspects of our department is having a laboratory for gastronomy. We talk about food starting from we don't do any food cultivation. We are not breeding specialists in our department, but once we have food in our hand, let's say grains, let's say some protein containing matrices, we take it from there. It could be processing, it could be extracting, it could be improving their techno-functional properties, it could be understanding their chemistry, or it could be improving their flavor properties. And we also study, once you eat food, to what extent it will be digested in your body. What is the digestibility of fat? What is the digestibility of proteins? What will be the digestibility of the carbohydrates and stuff? And those are the investigations we do in our department. So that's our key expertise. Yes, this is about our department, and now I'll start the real topic of today's lecture with this beautiful picture of cow. How many of you have seen a cow in your life? I can tell you that cow is one of the most important animals that revolutionized the human life, according to me. That's true, right? Since in the modern modern era, cow is an important organism that has fed us throughout our human history, I would say. We know that cow gives an important food called milk, right? Milk. And you must have studied in your primary school, whenever this milk comes in your science topic, they call milk as a whole food, right? It's a common thing we have been taught. It's a whole food because milk contains almost all nutrients that we need in a very good proportion. It has 3.5% of protein. It has around 4% of fat. It contains almost all good minerals that we need. It has a very high amount of calcium. That's important for our bone development, for example. So we are always told that you need to drink at least a glass of milk every single day to maintain a good health. From milk, we can also produce a lot of different kind of products. Let's say cheese, let's say yogurt, let's say buttermilk, whatnot. And sir was talking about paneer, and it's also coming from milk, right? It's not just about food. These are all about the business, right? Like there's a lot of industries are relying on cow. There is a milk processing industry, there's a cheese industry, there's a paneer industry, there is a butter industry. There's a huge amount of industries focused on cow, holy cow. It's really nice, right? And cow is also a major source of proteins, especially the meat proteins, what we call beef. I know in Indian continent it's less consumed. However, if you come to go into the rest of the world, beef is one of the most consumed meat. If I'm not wrong, 1/3 of the meat consumption in the world is actually beef. The first one is pork, the second one is chicken, and third one is beef. A lot of beef is being consumed around the world, and it's a fantastic source of proteins. About 25% of beef contains a very high quality proteins. That's really good. We don't have to blame for that one. It's really high quality protein beef does contains, but important thing is that we need to eat them in a moderate quantity, otherwise you have other problem. That's another story. And cow also gives cow dung, right? And that is also an important source of nutrient. Of course, we don't eat cow dung as it is, but we take cow dung and we make it as a fertilizer that goes into our paddy field, and we grow rice, we grow pea, we grow other things using cow dung as a fertilizer. It has a very good amount of nitrogen in it, right? It's very important for the cultivation in the agricultural field. So we again convert dung into protein. Do you agree? So we get peas, we get rice, we get all other vegetable crops. We not only proteins, we convert cow dung into carbohydrates, we convert cow dung into fat. So it's also an important source of nutrients, even dung. It all looks very good. But what is the problem now? I'm talking very good thing about cow. It is really good, fantastic. But apparently, cow is also a problem nowadays. Why? Now we can look into how actually cow produces food. Or how exactly cow produces milk? How exactly cow produces beef? Let's look into that one. How they eat grass. Do you agree? Yes, you should agree. So cow will eat grass, right? It eats grass, and the grass contains, let's say, proteins, contains carbohydrate, contains a lot of fibers, and it will go to the stomach of the cow. There will be digestion system. It's very different than the human being, right? And there will be so-called enteric fermentation inside the cow's gastrointestinal stuff here, right? And during this fermentation, there's a lot of bacteria involved in fermenting and converting its high quality fiber into individual sugars. There should be fermentation. And during that process, cow releases methane, right? Usually as burp, it burps. And apparently, methane is one of the most important greenhouse gas in the world. You know about greenhouse gas, I'm pretty sure. You know about greenhouse effect, right? Global warming, you must have heard. There is some gases like carbon dioxide, methane, nitrous oxide. They are called as greenhouse gases. If they are more and more accumulated in our atmosphere, when the sunlight falls into earth, the heat radiation, let's say IR radiation, these will be absorbed by these greenhouse gases, and they retain the heat in the atmosphere. When the atmospheric temperature increases, in the polar region, ice melts. When the ice melts, sea level rises. When the sea level rises, the coastal area disappears. Let's say Puri or Mangalore in our area. So they might disappear because of increasing the sea level. It's the biggest problem because towns are disappearing, biodiversity will be lost. So greenhouse gas is one of the biggest challenges that the world is facing today, and that is directly related to the food system. The power of this methane as a greenhouse gas is 20 to 80% higher than carbon dioxide. It's really a potent greenhouse gas, right? And the cow dung also contains small amount of methane, but mostly nitric oxides and so on, the nitrogen compounds. And that's also continuously released to the atmosphere when you do it agriculture and so on. And that's the reason why cow apparently a bad animal at the moment. I'm not telling that we should reduce it, but it's actually there's a systemic problem on animal husbandry today. So more cow means more greenhouse. What I'm telling, if you consume more and more animal-based milk, more and more animal-based meat, you need to raise more and more cows, and that will have a huge impact on the environment. Just keep that point in your mind. Now, this is a fantastic figure I downloaded from the internet, and you can see the greenhouse gas emission per kilogram of food product. Now we can look into the cow here, right? To produce 1 kilogram of cow meat, let's say beef, the biomass here, it is emitting about 100 kilograms of CO2 equivalent. CO2 equivalent means it covers methane, nitric oxide, and CO2 itself, right? So 1 kg of meat, it will release to the environment about 100 kilograms of carbon dioxide. Trust me, that's really a lot. 1 kg and you have 100 kilograms. So there is no good proportion here actually. Now if you look into, let's say, cheese, about 23, chicken about 10, milk about 3. Now if you look into the lower part here, this part, right? They're all plant-based or vegetables or fruits or nuts. If you look into their environmental footprint, it's sometimes 1 in 100 when it is equivalent to the animal, tenfold, 20-fold, 30-fold lower than the carbon footprint what the animal husbandry will have. So this is an excellent example to show that why we need to have a transition towards more plant-based food system. Does that make sense? So we talked about cow. Cow is good. We also talked about cow is not so good because it releases methane, right? So there is a high carbon footprint here. To have the sustainable environment of the mother earth, so we need to have a plant-based diet. Keep that point in your mind. This is a nice figure. I got it from this journal, from Annual Reviews. So here it clearly shows the dependency dependency towards the animal-based proteins. Or here you can clearly see that we are here, India, right? Asians, right? And we have here Americans, North American people, right? You can clearly see this is Europeans over here, right? you can clearly see that historically Asians are less dependent on animal-based food products. But if you go to North America, if you go to Europe, meat is the fundamental thing in their daily dinner. It's a fundamental thing. I was telling in my introductory speak that if you come to my home, only if the guest comes, we will have meat. Otherwise, it's only vegetable. Most often it's vegetable or sometimes fish and so on. That's very normal. I don't know about Odisha, you eat more meat, if I'm not wrong. But if you come to Karnataka, although we are non-vegetarian people, we focus more on the vegetables in our daily diet. But meat and milk often comes every time. But meat is like an occasional thing, right? But that is not true when you say the European continent or North America. They heavily rely on meat. And I can tell that probably they are also responsible for more greenhouse gas emission, right? If I talk about this particular graph at least. So it is important on an American point of view or a European point of view, they need to have this transition from animal-based to plant-based. Does it make sense? It does not mean that we are happy in the Asian country, we should not do anything. We also have to do something because we are actually raising a lot of cow in India and most of them is exported, right? And we consume a lot of milk in India and that's actually there is a huge carbon footprint. So now I just mentioned that, okay, meat is bad, not so good for the environment, eat more plant-based food. That's nice. But there's also a small glitch here. These things might really work well in the Western world. Let's say Europe, let's say America. If I say that, okay, you need to buy more plant-based foods, they can easily buy them simply because economically they are really rich, right? So instead of buying meat in the supermarket, they can easily buy a plant-based stuff in the supermarket. That's a straightforward thing for them. But there are other parts in the world, let's say Asia, let's say Africa, for them the food is a big problem. It doesn't, I mean, it's very difficult to say go and eat plant-based. If you go to, let's say, an African country, they're highly relying on milk because they have cow herds, they milk and they drink there. That's their life. So if I say that now you don't drink animal-based milk and you eat something else, there is actually a problem with hunger now. Right? So we need to find out a fine balance. We need to feed enough people. That's one of the problems, food security. And it's very difficult to have a complete transition to animal to plant-based. Then the problem is that, especially in some part of the world, there will be a misbalance. Then they might not get enough food. For example, there are some part of the world, they have, let's say, goat or lamb, and that's in their daily diet because they have hundreds of goat and they rely on goat milk. There are some countries they rely on camel, they rely on the camel milk. I can't go and tell them, no, don't do this, eat soy milk, drink soy milk. It doesn't work like that. Then we have a hunger problem there. So it's a very difficult situation we're at the moment. So we need to feed enough people and we need to feed them more sustainability. And that's the time point we are now at the moment. That's where the world political leaders are working on. How do we balance these two things together? This is a very nice slide I always show in my presentations. So you know that what is the population of India? So India has a population approximately 1.4 or 1.5 billion-ish. Do you agree? And the world population is how much today? 8 or 7, approximately 7 billion is a world's population. And it is said that around 220, by 2050, the population going to reach approximately 9 billion. The world's population is going to reach 9 billion. So we have a surge of increase in the human population. And please note that when you have more and more people, we need more and more food. But the problem, what is happening, at least in our surrounding, we have more and more people, but the agricultural land is diminishing. And basically, the food production is kind of dropping. You know that the price of food is also slowly increasing. In India, it's increasing at much rapid rate, right? So the population is increasing and we need to have more and more food. That you have to keep in mind. So that means we need to increase the food production approximately 70% to feed more people. I'm already told that 1 in 9 people are already hungry, but I don't know if we continue rely on our current food systems, which is animal and small amount of plants, many people will fall hungry in by 2050. We really have some problem. The current food system is like this one. Like you have, let's say, grains, vegetables, and whatever. So plant-based here, and then we feed that into. Does it look like a chicken? This is chicken, huh? Okay. So we feed into chicken, right? And then we human being eat chicken. So this is the way we are. Our food system is running at the moment, right? Of course, you can directly eat the vegetables also. That's another story. But majority is running in this direction. So to feed this chicken or animal or whatever here, we need more and more food, right? And that's what we call feed here, right? And now we don't want to have more animals, then there's a lot of feed left here, right? The question is that, okay, now we are producing more of them, where does that go? The idea is today's food system we are focusing is converting every feed into directly into food. That's how I'm going to talk about that one. That's what we call, let's say I have some example. Let's say rapeseed as an example. We use rapeseed press cake to cows to get more milk. You know, I don't know what we call it in Hindi. We call it as Hindi in Kannada, which is actually a press cakes. You know that you can buy from the market and feed into cows, which has around 30-35% protein. Now we want to eat that feed, but we can't eat directly feed because it's very difficult to convert feed into food because animals can't digest many things, but humans can't digest many things. We need to modify the feed. We need to convert feed into food ingredients and then incorporate into some food, then use it. That's the whole food value chain is going in this direction. I hope I answered your question. It's not that we're discarding anything, it's more about converting feed into food somehow. Now I can jump to food to proteins here. It said that we need, of course, more and more food. It also means that we need more and more proteins. If you talk to a nutritionist, they say that around 1/3 of your calorie intake per day should come from proteins, not from jalebi, right? 1/3 of your calorie intake should come from proteins. They say that 10 to 30% of energy should come from proteins because it's very important energy source, not from directly from carbohydrates. So more food also means more proteins. Does that make sense? And here is the graph. You really see that apparently it says that you need 15 into 10 to the power 11 kilograms of proteins per year, something like that. No, sorry, it's over here. So this is the amount of proteins we need. That means we need to now mass produce proteins as well. There it comes whether I need what kind of proteins I need to produce to feed the growing population. Okay? To summarize what I've been talking about now is that the first thing we have to keep in mind is food security. That means enough people should be fed. That's the first and fundamental thing we have to have in mind. To have the food security, one thing we should do is increase the productivity. Somehow you produce more and more food or more and more proteins. The second thing we need to do is you need to find the sustainable alternative. Don't rely on the conventional thing. Try to find the mother nature is very diverse. We are always told that whatever we need is already in here. Just have to find it, right? We just have to find it. We just have to valorize it, and that is a sustainable alternative we need to find. And we need to reduce the waste. I think 30% of food is wasted, unfortunately. So we need to reduce the waste, and we need to create food that is safe. I'm telling you about, okay, you need to find an alternative, but keep it in mind that we need to produce always a safer food. That's also a very important thing. It's not about producing more and more food. We need to produce more and more healthier and safer food. It's not just about amount, it's more about the quality, right? So I'm going to cover this particular topics in our GAN lecture. Okay, alternative food systems, a particular emphasis on alternative proteins.
Thank you so much for providing this knowledgeable information. My question is it practically possible to shift towards alternative proteins by decreasing the production of animal protein? Is it practically possible? Suppose if we go for the alternative proteins, they do not provide the essential amino acids which are required for the body, or they are not quality proteins.
Yeah.
So how we can manage it?
Yes, that's a good question. I'm going to teach around 3-4 lessons on that particular topic. How do we improve the quality of plant-based or alternative proteins? He's absolutely right that it's important to have this transition but usually milk protein is the best. Like, they have a fantastic digestibility, they have very good balanced amino acids in their proteins, good for even for the infant, it's also good. But plant proteins have a lot of other problems, so we need to have a technological innovations to convert them into edible high quality proteins, where the science and technology comes into play. And I'll cover and I'll give a detailed information on that particular in topic in my upcoming lesson. So this is the question that I really wanted to address. That, okay, I mentioned in my very first slide that meat is actually good in terms of nutrients. Okay, it has a good amount of proteins, and the meat protein quality is really good. They have a very good amount of essential amino acids. And meat not only proteins, also come with all the other things. For example, it has minerals, it has vitamins, it has very good amount of iron that we need, right? Now you can ask me questions like, okay, why we stop using animals, and why can't we just change the animal husbandry or change how animal produces proteins or something like that? Why can't we do that one? I tried to find this slide. How do we produce? I already shown that one in my previous slide as well. How do we produce meat proteins today? We give the feed to, let's say, chicken, and chicken comes to this box, right? This is exactly how we are producing meat, right? Now, if you take poultry as an example, trust me, apparently within 38 or 39 days, you will get fully ground farmed chicken. Only 38 to 39 days, right? Just imagine how much modification we have made to this poor animal to produce a big biomass in 38 days. Right, we have already changed everything in this particular organism to get high amount of protein, high amount of fat, and high amount of biomass. I think there is nothing more left to do is here. So there's actually, we are pushed to their biological limit. We already have cows that produces liters of milk, right? We already have chickens that's high quality and short time, good amount of eggs, good size of egg. We have done everything, almost everything. I think we need to also somehow have this ethical concern in our minds. Don't push them too much. So that's the reason why we need to have more find out other alternative sources. So as I said, to answer your questions, to answer all this problem, somehow you increase the productivity, find out an alternatives, or you reduce the waste. Those are the three most possibilities we have, and I'm going to cover these middle portion in our GAN program. What are the sustainable alternatives we have, and how we can have this transition from animal based to plant based. Okay. Now, how many of you have studied proteins in your let's say bachelor's or master's or primary school or high school? Proteins, about proteins. So you already know the basics very well, so I can skip these slides. Okay, now I ask this question. What are proteins? Can someone answer? Proteins are macromolecules. Proteins are made up of amino acids. Any other things? So proteins contains nitrogen. Do you know how many percentage of nitrogen does protein contain? 6.25 is a conversion factor to convert nitrogen into protein. So about 16%. So 6.25 is the universal conversion factor. So yes, any other thing you know about proteins? Proteins are amphoteric in nature. What do you mean by amphoteric in nature? Proteins contains both cations and anions. So they can be positively charged, they can be negatively charged. Good thing. Proteins are the building blocks. Some people goes to gym and get good muscles, right? Proteins are the building blocks in our body. That's right. Anything else? A lot of biochemical pathways are because of proteins. And if you look into this hypothesis or theories about origin of life from the abiotic stuff, they also talk about how life originated from ammonia to amino acid become protein, and protein becomes a life. So proteins are very important since our day one, I would say. That's good. Anything else do we know about the proteins? The last bench people, no answer I got from you. What do you know about proteins? So energy, so ATP to ADP, so energy conversion can also rely on proteins. I agree with you. Anything else? Do you know about proteins? So he is telling that without proteins we cannot survive. Absolutely. Without protein, no living being exists. So I think I'm very happy to see that you already know a lot about proteins. So let's begin with proteins. As a chemist, I see protein as a very beautiful molecule where amino acids are joined one another to form a huge macromolecule that becomes a protein. So individual units in a protein called amino acids, right? As the name defines, it contains amino group and an acid group, right? It's very easy to remember how the amino acid, there's a central carbon atom here, C, right? And then you have an amino group, which could be protonated. Then we have a carboxylic group, it could be a deprotonated. Amino acid, right? Amino acid. And by default, they have a alpha hydrogen atom here, and this is the side chain. This is the one varies continuously, right? And this is the basic structure of any amino acid, right? Remember that one. This is the basic structure of amino acid. And there was a person who was telling about proteins are amphoteric in nature. It's simply because there are certain amino acids where one of the side chain could be carboxylic group, it could be negatively charged, and there will be side chain called amino group, it could be positive. For example, lysine has a side chain with an amino group here, epsilon amino group, and that will give you the positive charge. So proteins can be amphoteric in nature. Okay. Now, two amino acids, they join together, and multiple amino acids attached together, they form a big proteins. That's true. Now, do you remember what is that bond that makes proteins that join? Peptide bonds. Do you agree? Let's take, we have an amino group and we have a carboxylic group here, let's say, right? And they can combine, leaving the water molecule away, and then you get a bond here that is something looking like this, and this is the bond called peptide bond. Chemically, it's an amide bond, amide, A-M-I-D. Since it is within the proteins, they call it as peptide bonds, right? So remember that amide bonds and peptide bonds, that is the bond that stabilizes the protein. They're very strong in nature. Only acids, base, and certain enzymes can cleave or hydrolyze these bonds. That you must have heard, right? There are some enzymes called proteases. They cleave the proteins into peptides, peptides into amino acids, and they change the functionality of the proteins. So they are actually cleaving this particular amide bond. Does that make sense? So now if I say proteins, in between them we have amide bonds. You are also telling that without proteins we cannot survive, right? Even I can say that starting from your nail until your hair, it is made up of proteins. Like you have keratin in your nail, you also have keratin in your hair. It's all proteins, right? And as I said, the muscles are made up of proteins. And somebody was telling all the biological processes are because of proteins. Why? Because there is something called enzymes. Have you heard about them? Of course, right? You're all bachelor's and master students. All enzymes are made up of proteins. That's a universal definition. Enzymes are proteins, right? But they're functional proteins. And apparently there are 75,000 enzymes in our body. They do job every single day, so you're happy. Sometimes you're also sad because of certain enzymes, right? So there's a lot of enzymes in your body. They're all coming from proteins. And it is said that we need to eat enough amount of proteins, otherwise one fine day you will die. Otherwise also you will die, but you need to eat more proteins, otherwise you'll die sooner maybe, right? So it's said that we need to eat approximately, I think, if I'm not wrong, 0.6 grams per kilogram of body weight. It's approximately 60 grams of proteins we need per day for the normal life. Okay, I think Western people eat 60 to 80 grams. Indians eat around 20 to 30 grams. We are less protein consumers. We are more carbohydrate consumers or fat consumers. But it said that you need to eat 40 to 60, 70 kind of proteins every day to maintain your body weight. And as I said, proteins are made up of amino acids. How many amino acids do we have? 20. So there are 20 proteogenic amino acids. They are combined in different permutation and combinations. They make the proteins. Okay. You should remember this blue region, that's the only region where there's a change, the side chain. This part is constant, you can see that one. Okay. Actually, the amino acids are the one that gives some properties to the proteins. All right. Some proteins are water soluble, some proteins are salt soluble, some proteins are alcohol soluble, some proteins are completely insoluble. It's simply because how this amino acid composition that this protein has and how they are folded, whether they can interact with water, whether they interact with salt solution, whether they interact with alcohol. Based on that, the solubility is determined, and that's again dependent on the amino acid composition. Does that make sense? Because for example, there are some amino acids which has hydrophobic region. Let's say phenylalanine here, like that has an hydrophobic benzene ring, right? So it doesn't like water a lot. Phenylalanine is like less water soluble. Tryptophan we have, again it has an aromatic compound. Um, this moit, it doesn't like water a lot. So if you have more and more, let's say other hydrophobic region, yeah. Now there are certain amino acids with the charged compound, amino group, positively charged. The charged compounds likes water, so they're more and more water soluble. Like depending on the side chain of the amino acid, solubility changes. Please note that as a food scientist, solubility is one of the important aspects you need to keep it in mind. So if you start studying about functionality of food protein, the first thing you do whenever you extract the protein, trying to test how soluble it is. Because solubility is the one determines the protein quality in most of the food application. Okay, and that is depending on the amino acid composition. And that's the reason why when you isolate a plant protein, people will immediately do the amino acid analysis to find out, okay, what kind of protein does it have. And then other thing you need to remember about essential and non-essential amino acids. Can somebody define for me what do you mean by essential amino acids? Essential amino acids are those our body cannot synthesize in the required rate. They might synthesize some, but not in that much rate. So we need to take it from as a food or a beverage or whatever. So we need to eat through our mouth, right? Our body cannot synthesize, and then it will be rehydrolyzed. They will be hydrolyzed in our body, in our stomach, and then the new protein will be synthesized in our body. So the building blocks we need to continuously supply, and that is called essential amino acids. There are 9 essential amino acids. Please keep in mind there are 9 essential amino acids that we need to eat every single day. Okay, and then there is something called conditionally essential amino acid. That means sometimes we need them. For example, if you have some diseases, if you have some disorders, if you have, for example, elderly people, we need some young infants need, children's need. So there are certain conditionally essential amino acids. There are something called non-essential amino acids. That means these are the amino acids we generally don't need because the body can synthesize them from other amino acids or some other nitrogen sources. So we don't have to eat them, right? But usually proteins are made up of all the three in different proportions. Do you agree? It's very difficult to find a protein with only essential amino acids. No, nothing exists like that one. Usually they are mixture of amino acids in different proportions, and that determines the protein nutritional quality as well. But you need to find the proteins, we need to find an alternative protein which is rich in essential amino acids. It's a fundamental thing. Then I'll talk a little bit about protein structure. It's also very important for food scientists as well. Proteins contains a very beautiful structure, right? And that can be subdivided into 4 structures. One is called primary structure, second one is secondary structure, tertiary structure, and quaternary structure. The primary structure is the basic structure of proteins. How individual amino acids are joined each other is the primary structure. And that talks about the nutritional quality. Okay, how much essential amino acid I have, how many lysines I have, how many peptide bonds I have. These are the information you get in the primary structure. Then we have secondary structure, where we talk about the protein, how they are bonded to each other. For example, we have 2 kinds of secondary structure, alpha helix and beta sheets, right? Basically, you have an amino group, we have a carbonyl group, and they can form a hydrogen bonding between them. And that stabilizes the structure to get a bending as a helix or as a sheet. right, because of the hydrogen bonding, and that gives you the secondary structure to the protein, right? Probably you're using IR equipment to find out the secondary structure of protein when you do the technofunctionality analysis, right? And then we have a very important thing is called tertiary structure, and that talks about the three-dimensional structure of protein. Please note that the proteins are not linear, they're not flat. They have a beautiful three-dimensional structure, right? They're bent like this one, right? They're folded. You can't say proteins are like this. They are actually globular. They could be a different shape, and that is because of their tertiary structure. And that's again stabilized by hydrogen bonding. And sometimes you have this disulfide bond. Can you see here? It's where two cysteine can be joined together that can bring two protein on the protein strand bent like this one. So you get the folding because of these disulfide linkages, right? And the folding is very important, and the disulfide bonds are very important even in determining the functional properties of proteins. For example, you must have heard about gluten in bread making, right? You get this nice elastic band, when you make a dough for bread, and that's because of this extensive disulfide linkages you have it in the gluten protein. It provides these technofunctional properties, right? And you talk about creating protein aggregates, right? Whenever you talk about protein functionality, we talk a lot about aggregates, and those aggregates could also be stabilized by this disulfide bonding. So the tertiary structure is also very important, that determines the protein's functionality as well, okay? Because if you talk about the solubility of the proteins, now if you imagine, if I want to have a protein water soluble, I want to have a protein water soluble. What does that mean by water solubility according to you? It should get dissolved in water. How a protein will be, how any molecule will be dissolved in water according to you? It gets polar units, right? If you have a surface amino acids with polar functional group, let's say hydroxyl group, ammonium groups, carboxylic side chains, they're all a little bit polar, right? And the water molecules likes the polar compound. You studied water likes polar. Polar likes polar, non-polar likes non-polar. So water is a polar solvent, right? So if you have a more polar structure on the protein, they can interact with water molecule. That is called protein can be hydrated, right? And that is depending on how exactly the protein is folding, right? If every polar residues are inside the protein, when they're folded, it becomes less water soluble. Do you agree? Because the non-polar thing is outside, water hates non-polar stuffs. It doesn't want to dissolve that molecule, then the protein precipitates. It becomes insoluble. So if you have more and more polar residues, probably they become more and more water soluble, right? So that's the reason why the tertiary structure of the protein is very important. How well they fold, that determines the solubility, that also determines the how it interacts with oil. For example, you must have studied about oil holding capacity. There are certain amino acids they love oil because it's non-polar. So that depends upon the folding. Then we have the last thing is quaternary structure. It's very important in the biological processes because when multiple protein subunits together make a quaternary structure, they can be stabilized by again hydrogen bonds and disulfides here. But I'm not very sure how important it's for the food systems because often food is heated, right? You cook it, you ferment it, or you pasteurize it. There's a small amount of heat and storage is always associated with. It's very difficult to say whether the food proteins will maintain the quaternary structure throughout their lifetime, because during different processing, these will be disintegrated, they become individual units. So it might be important or might not be important, I don't know. There's a lot of research going on in that area. But these three structures are very important for proteins functionality in food system. And this is extremely important for the protein functionality in biological system. Let's say enzymes. Enzymes should have this quaternary structure in some cases to have the biological role. If you look into the amino acid structure like this one, can you see the carbon here? This is alpha carbon. The carbon that is bonded to the functional group is called alpha carbon here, right? This is alpha and this is B. For example, this is a beta carbon here, this one. So chemically speaking, this is the alpha carbon that is bearing the amino group and the carboxylic group. Now I have to talk about a little bit chemistry. With alpha carbon has a lot of role because let's take this is an alpha carbon. with the hydrogen, and then there is a carboxylic group, and there is an amino group here, let's say. And this is the carbon atom that can be paired to hydrogen atom. That is a very important role in the chemical reactions, basically, because this hydrogen can be donated. For example, if you have an excessive hydroxyl group, this can be taken by this one, and you get a carbanion like this one, negatively charged. And then basically that is having a role in converting the amino acid from L to D, for example. You know that all the amino acids we have in the world, most of them, 99% I would say, is in L or D form, L form, right? Our body can only recognize the L amino acids, right? Our body can, the enzymes can recognize the L amino acid, they're bioavailable, they're healthy. But if you do the processing, alkali extraction, for example, you can convert L into D by this particular process, where you remove the hydrogen and the incoming hydrogen can attack in the opposite direction. The L amino acid becomes D amino acids. They are not nutritionally important. And where the carbon, this alpha carbon has a huge role, the tendency to convert them into biologically non-functional amino acids.
You told that these alpha L changed to D. Then how it is possible for us to replace these animal proteins by these alternate?
Good question, but I'm not telling that every protein will convert L into D. There are certain amino acids, depending on the alpha carbon here, they have a more tendency to form D amino acid. For example, if I'm not wrong, glutamic acid can become more L to D, not every single amino acids. All right, so then about little bit about isoelectric point. Have you heard about that one? Isoelectric point. So it's an important parameter so you always use in food proteins, right? Isoelectric point is the point as a pH where the protein have the lowest solubility. Proteins will have different solubility depending on the pH of the solution, right? Now imagine I take a beaker here, right? I put proteins into it, and the pH of this solution here, let's say 3.0, acidic in nature, right? When the pH is acidic, the solution is acidic, pH is around 3, let's say, then the protein will be positively charged because the amino acids will be protonated. Most of them, not all of them. If not all of them, most of them will be protonated, right? Now, if you have proteins positively charged, all the proteins becomes positively charged like this, right? I think you have studied in your primary school again. Positive charge does not like positive charge, or am I wrong? Yes, I'm right, right? So if I have a protein positively charged, other protein is also positively charged, they tend to repel each other. They don't want to come together. But usually the positively charged is liked by water molecules because they have a negatively charged oxygen, let's say. Then the protein will be continuously hydrated, then the protein will be solubilized. All right. So in the acidic condition, in this particular region, let's say proteins are more positively charged, they like water molecule. Okay. Same thing is true in this region, the basic conditions, the protein will be negatively charged because you deprotonate them. And negative charge does not like negative charge. If you have two proteins with negative, 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 they hate each other, they go away. But they like water molecule, they become more and more water soluble. Does that make sense? But at the pi, what happens is that the protein will be having equal amount of positive and equal amount of negative charge. Then what happens? We know that positive loves negative, negative loves positive. Now the protein will start interacting with them each other. The protein interaction will increase. When the protein interaction increases, they don't want to love water molecule any longer. I don't want water anymore. I just love my another partner, which is protein. So they interact each other, they precipitate. Then you have the lowest solubility, right? And some people say that at pi you have the charge is zero. That's wrong. The pi, the charge is not zero, the net charge is zero. That's the difference between charge and the net charge. At the pi, there is a charge on the protein. That's the equal amount of positive and equal amount of negative. The net charge will become zero, so they attract each other, they precipitate off. Okay, and in this region, you have more net positive charge, and if in this region, you have more net negative charge. Right, and then they like water molecules. To summarize this one, please remember And the acidic conditions, usually protein water interaction is higher. In the basic condition, protein water interaction is higher. At pi, at the pH is equal to pi, there will be more protein protein interaction. Okay, and every protein will have its own pi, not necessarily 4 or 5 as I shown here. It's about, I think it's from soy protein here. It varies. For example, beta lactoglobulin, if I'm not wrong, 5.5, and we are working with napin, which is having around 10 or something like that. So it varies depending on the proteins. So why I'm talking about pi a lot, it's very important thing in food proteins. As I said, protein in the food in some cases has to be soluble. For example, if you're trying to make, let's say, sports drink, right? Sports drink should contain a lot of proteins because they like to build their muscle. But if the sports drink has very turbid, nobody would buy that one. They want a clear solution. It looks like water, completely soluble, but it should have 20% of protein. Okay, and then the pi becomes an important role here. Now you have to find out the protein that is soluble in water, then the people can buy it. So every protein cannot be used for every application because they have a different pis. Okay, so you need to find out the protein with the right pi to use in the right food application. All right, then a little bit more basics, that we have two class of proteins in plant food world. One is albumins and other one is globulins. Just remember this one, I don't want you to by heart. Albumin is water soluble, globulin is salt soluble. Albumin likes water, globulin likes salt solution. Okay, just remember that much. Albumins are also globular protein, and globulin is also globular protein usually. So don't get confused, right? It's only about solubility. Albumins are water soluble, they're also globular protein. Globulins are also globular protein, but they like salt water. Like they're more soluble in, let's say, sodium chloride solution compared to pure water. The traditional protein sources, it's a nice figure. I can show you that if you look into here, you can see that these are the vegetarian and these are the non-vegetarians. And I leave egg here because I have a close friend. He always call egg as a vegetarian thing. So I don't want to categorize it to not to make him unhappy. Maybe he's watching my YouTube video. So I don't know whether it's vegetarian or non-vegetarian. I'll leave it in the middle. So you can see that usually non-vegetarian stuff, animal-based, has a high protein content, and plant-based stuff has a low protein content. Exception is nuts and seeds. They have a really high amount of proteins, right? But if you eat more and more chicken, fish, and poultry, and so on, you actually consume more and more protein. Just keep that in mind. Okay. Now I'll leave a little bit to the topic, that is alternative proteins. Anything that is different than what we have been using traditionally can be called as alternative. Just to divide things into two sides, traditional and alternatives. Alternative proteins by definition is nothing but the proteins that is different than that is originating from beef, poultry, pork, fish, seafood, eggs, and dairy. Okay, I don't like really that people call plant proteins as alternative, because we have been using it, at least in an Indian context, we have been using it since ancient time. So it's a part of our diet. But on a scientific world, even plant-based proteins also comes under alternative food category, and I'm going to teach them as alternative. Just don't mind. Is it okay? What are the most important characteristics that you need if you want to buy an alternative protein in the supermarket or a food containing alternative proteins? What is your expectation? What do you want in that? Just discuss that one.
It should have good digestibility.
So he is telling that the one should have good digestibility. Okay. When I say good, what do you mean by good digestibility? How much you're expecting?
Something comparable to the conventional proteins.
Exactly.
More bioavailability.
Digestibility and bioavailability go hands in hand. Bioavailability. Okay.
Amino acid composition.
Good amino acid composition, right? Yeah, amino acid composition. There, what did you guys discuss?
Quality.
Quality. So quality, we need a good quality proteins. What do you mean by quality according to you?
कितना टाइम वो रहता है प्रिजर्व होके, या फिर कितना टाइम
Exactly, the stability should be high enough, right? It should be having a good stability.
Yeah.
Good point. So high quality means maybe good. You need to find a protein that's stable in your For example, if you want to make a plant-based infant formula for your baby, for example, maybe food is stored for like 1 year sometimes, right? It's somewhere dumped. I want that protein to be stable for 1 year. It should have enough stability. It should not degrade. It should not produce unwanted harmful compounds. It should not change its flavor. So you need to have a good stability. Very good point. Good quality means good stability. Anything did you discuss? Anything else?
Protein content.
The content, that means the quantity is also important, right? If you're looking for an alternative protein, it should be available in bulk. It's not about small amount, only 100 people in the world can eat it. No, we need to feed a significant portion of the population with this alternative protein, so it should be sufficiently high quantity. Whenever you do research, it's nice to work on small amount of this unknown stuff. It may be a good publication, but if you really want to have an impact on the population, you need to look for the protein sources which is abundantly available so that it can feed a large proportion of the population. Keep that in perspective in your mind when you do the research. Yes, quantity is important.
It should be environment friendly.
Exactly. We need to find out sustainable sources and sustainable way of processing. It's not that I will find a good high quality proteins. However, my carbon footprint is next to beef. No, I don't want that particular protein. It should be sustainable. It should be, the processing should be easy enough. That is environmental friendly. Very good point. Anything else?
Sir, it should ensure the global food security level.
It should ensure the global food security that actually I just discussed the same thing. It should be abundant enough so that people can use it, or it should be at least enough that local people can use. That's also a part of sustainability. It's not that you don't have to export everything into other country or other state. Can you at least locally consume it? That's also a part of sustainability. Anything else? Sensorial property is very important. Is sensorial property. Human being never eat anything if it does not smells good, doesn't taste good. And the third one is coming, the nutritional value, the digestibility. There was actually called an halo effect. For what does it mean? Earlier the people thought that okay, proteins are very important, good for the environment, good for your body and so on. They started loading more and more protein to the food products. More is not always better, the best, right? More is just more. You need to find somebody who's talking about the quality here. It's more important to have the high quality protein. That means they have to be digestible in your stomach. So the digestibility should be sufficiently enough. We call PDCAS, DIAAS. There's a lot of way to measure IVPD and so on. I'll take that in the later classes. So digestibility should be sufficiently enough. And now important thing that we are in the era, it's not just about digestibility, it's all about bioavailability. Okay, in your stomach they're digestible. Is it actually going to your bloodstream? Or is just going in the feces? Does it make sense? So it should be enough digestible. Not only enough digestible, it should be enough bioavailable. And that's where actually the science is going nowadays. Please note that somebody told about there should be enough good amount of amino acids. It's not about having the one type of amino acid in high quantity. That's also bad. If you have more lysine, less methionine, that's a bad thing. Why? Because when you eat this protein through your mouth, it comes to stomach where it will be partially digested. Then it goes to your small intestine where it will be almost completely digested, right? Then there are certain carriers, again they are proteins, they carry amino acids on their head and take to the bloodstream, right? There are actually these active transporters, they don't carry only one amino acid, they are carrying 5, 6 amino acids. They have specificity for different amino acids. Now if you have a protein with rich in one amino acids, they get confused. Should I carry the only one I'm seeing now, or should I leave the other one which is very small, present in very small amount? Right? So you need to find the balanced amino acids. That's very important, right? It's not about having one in the high quantity. It's very important to have the balanced amino acid proportion. Then only they become more bioavailable and become active in your body. Does that make sense? It's not just about digestibility, it's more about proportion. Okay? And that's something very important. We have to keep it in mind. To conclude, 4 things are very important. The first one is the perception, the sensorial stuff, right? The color, the flavor, the taste, the texture. This is very important. The second one is digestibility is very important. The bioavailability is very important. The third one is amount is also important. That means how much we are producing is important. The fourth one is sustainability. We need to produce them in the most sustainable way. Then only we tick mark it as an alternative proteins. Trust me, there is no alternative protein that tick marks everything. One is better with purity, quality, maybe bad in digestibility. One is better in digestibility, but no enough essential amino acids. There's always a problem, and where we food scientists come into play, we try to tweak things. We try to mix different things. We try to remove the anti-nutrients present in the together with proteins to improve the digestibility. And where the research becomes super, super important, right? One thing, the take-home message for today is that don't believe in only quantity. It's not always about quantity, it's more about quality. You need to important to have a high amount of protein, but high amount of high quality protein is very important. They're digestible, less unwanted anti-nutrients, less amount of unwanted flavors and so on. And that is something we need when we say the alternative proteins. These are the traditional, basically meat and milk based one, and I'm trying to cover the alternative today: plant based, insects, microalgae, and fungi. Let's begin with the plant based foods or food proteins here. So we have soy, we have pea, we have fava, moong, sunflower. There's hundreds of different things. They are rich in proteins and they can be used as protein source or source for the protein ingredients. I'm talking about two things here. Please note that when I say plant-based foods, it could be a whole food. For example, in Indian diet, we use whole food. For example, dal. Okay, there's a whole food. We take dal, maybe a split dal, and we cook it and we eat it. But if we come to some other part of the world, they don't have to eat proteins from dal as dal, but they take proteins from the dal and convert it into burger and then they eat it. And there the ingredients come into play, where the processing come into play. Am I clear? So they are also good sources of protein ingredients to convert into different kind of foods. Please just remember that we need to also respect people's tongue also. You can't feed dal to every person in the world. It's sustainable, but not. I don't want to eat dal every single day, right? I want milk. I want something to tear. I want something to chew. It's human beings are so crazy, right? We don't want to eat the same thing every single day. So we need to create food with different kind of texture, flavor, and so on, where the ingredients play into play a significant role, and where the food processing becomes so important. I'll try to cover those things as well. Okay. So let me try to begin with the most investigated plant protein today is soy. Okay, if I'm not wrong, soy and gluten, the wheat gluten, are the well characterized, so much investigated, so well investigated plant proteins today, soy. So if you go to USA, America, you will find in the supermarket hundreds of different soy based food products. Soy is extensively used in the US actually. So if I'm not wrong, the USA itself is the one of the largest, no, it is the largest producers of soy. And then Brazil and then China or Argentina is also producing a lot of soy. Okay. When it comes to composition, soy contains about 30 to 40% of proteins, very rich in proteins, also other fibers and so on. It also comes with all unwanted compounds like trypsin inhibitors, phytic acid and so on, which I'll cover in an upcoming lecture. So the most important thing it contains is protein. Okay. When you come to the product, soy milk is one of the most sold milk alternative in the world is soy milk, which contains around 1 to 4% of protein. How many of you drink soy milk here? It's not very popular in India, right? You don't find that often in a regular market. But if you go to Europe or if you go to America, it's one of the very common milk alternative is soy milk. Okay, it's also consumed a lot in China. Have you heard about tofu? It's a meat alternative in China, in Korea, also nowadays also in India. It's basically, I would say it's a paneer from soy milk, right? It's paneer from soy milk. Paneer is produced in India from cow milk, and if you precipitate soy milk, the protein will coagulate and forms tofu. And tofu has a very nice texture. It's like paneer, but it comes in a different texture. You can get it a very soft, very hard, and you can make it a different texture. It can be cooked to get like a meaty kind of texture. Okay, I'm pretty sure you know about sauce, right? If you go to Chinese market, what we call gobi Manchurian or fried rice and anything, that soy sauce they add, it's actually a fermented soy product. They use, let's say, fungi, aspergillus or something like that to ferment soy, and the protein is partially hydrolyzed here, and then you get the soy sauce, which is traditionally used in China and Korea and Japan, and now also in India and also in European market. Okay, and this is very popular in, at least in India. When I was in the hostel here, when I was studying in NIT Surathkal, I would always get soy and aloo together and to make the curry out of this one. It has around 50% of protein, extremely rich in protein. I never liked it when I was there, that it has a texture like chicken, but really not chicken. I was really confused when I ate first time. Am I eating chicken or it's a soy? It's a very popular in, if you want to produce mass proteins rich food, then the soy is a good option. Soy chunk is a good option. So when you come to soy proteins, you have 4 types of protein. The main one is storage protein. Storage protein is in the seed, they actually accumulate as a storage proteins. Okay, and mainly the soy contains globulins. Remember, the globulin is salt soluble proteins, and 2 types of globulins we have: glycinin and conglycerin. Glycinin we have 40%, and conglycerin we have about 25%. And glycinin is actually an hexameric protein. Hexameric means it has 6 units of proteins, the quaternary structure, and clonglycin, I think it's a trimeric proteins. If you take soy protein isolate and do the STS page, have you done STS page? How many of you have done STS page? It's an important technique. I'll teach about that in the next class. So to separate proteins, you can see number of bands. You can see the conglycerin and the glycinin. So glycinins are the low molecular weight compounds, and conglycerin is the high molecular weight proteins. So these are the 2 major proteins it has. And the one important thing is that where it is, the soy contains a very good amount of essential amino acids. It's very equivalent to milk proteins, and it's higher than what we need per day actually. So that's the reason why the soy was extremely popular replacement of milk proteins. It contains almost all essential amino acid, and sometimes they have a less amount of methionine depending on the varieties and so on. They have a small amount of the less methionine and cysteine, but it's actually having the equivalent to milk proteins. It's actually a very high quality protein. And the digestibility of soy over here is very similar to milk. According to PDCAS, protein digestion corrected amino acid score, according to PDCAS, is one of the measurement we use to see the digestibility of protein. I'll talk about PDCAS, DIAS, IVPD in the next class. Don't worry about it. Just remember the PDCAS is one of the, now we are not using it much. It's the measurement to assess the digestibility of a given protein, and milk is 100% digestible. It's called as 1 here. When compared to milk, soy protein isolate, for example, is 100% digestible. There is no problem with soy in terms of digestibility, and you can see that the pea and barley has a low digestibility compared to soy. So you can use soy as a food ingredient without any problem. So whenever you see plant-based research papers, they use soy as a control in addition to casein. If you're working with pea, if you're working with, let's say, rapeseed, if you're working with, let's say, duckweed or other or insects, they always try to use soy as a reference standard here because it has a very good digestibility. All right, so we have been discussing about soy, and I mentioned that the soy can be eaten directly, in the sense after fermentation, after getting soy milk, after boiling, or as a tofu. But in the modern world, we are using soy to get soy-based ingredients. It's very difficult to use soy in every situation. However, we can get the proteins out of soy and we can create new foods using soy-based protein ingredients. Okay, and there we are, there where the food processing becomes super important. So first one we talk about soy flour. The flour is simple. Basically, it can be you just take soy, dry soy, and you crush it and get the flour. And usually it is defatted. Remove the soy oil, and you get this flour devoid of oil, which is containing about 50% of protein. It's a fantastic ingredient to replace or to get, let's say, baked products. It could be bread, it could be cookies, it could be other things, right? Where you just replace the regular, let's say, wheat or other flour by soy, and it's already in the market. It's being extensively used in, let's say, in some part of the world. Okay, there's no much processing involved here. Just replace, let's say, wheat with flour, not 100%, but usually partially, like 20%, 30%, because you still want to get this gluten network, and it's not possible to get that completely with soy. So you can replace a part of wheat flour with soy flour. Okay, and then it comes more about the business part here, that is concentrates and isolates. I think you've heard this word, right? Concentrates and isolates. It's one of the things we are widely using in food processing sector. So basically, it's something about the purity of the protein, right? There is no definite definition for here. Usually, we say that a scale 70 and 90. Okay. So anything that is around 70 to 90%, we call it as concentrate. Okay. Some people say 60, some people say 70. There is no definite rule. It's just an opinion-based thing. So 70% of protein in the powder that you get, or the biomass what you get, if it's minimum 70%, maximum 90%, then we call it as protein concentrates. Anything above 70, 90 to 100%, and that is called isolates. Isolate. Okay. Anything below that, usually we call it as flour. Does that make sense? 70 to 90-ish is called concentrates, and 90 above is called isolate. It's nothing but the protein purity, right? If you have more and more protein, it becomes isolates. For example, if you have 90% protein and 10% should be carbohydrates, it could be small amount of fibers, it could be small amount of metal ions, it could also be small amount of anti-nutrients. So you're increasing the protein purity. Basically, when you have more purer and purer protein, you will get a different functionality, in other words. Somebody asked about the flavor. The problem with the plant proteins at the moment is the flavor. You can always use protein concentrate. It's very cheap. In basically, the soy concentrate is not that expensive because it's easy to produce, but it has 70% of proteins and 30% of unknown things. It could be fibers, it could be anti-nutrients, it could be minerals, and they actually provide some unwanted benefits. Sometimes they becomes more bitter, sometimes they are not digestible because of this anti-nutrients present. Then you have to purify soy into isolate level. But remember, converting the flour into concentrate and flour into concentrate and concentrate into isolate requires processing. Do you agree? Is more and more purification step is needed. When you purify more and more, basically the yield is reducing. Do you agree? It's always the problem, battle between yield and purity. If you want the highest purity, you compromise with the yield, right? So you also increase more and more processing. More and more processing means more and more environmental footprint. So you need to find a fine balance. If you can use concentrate, try to use concentrate. But if you really want to use isolate because of a special application, try to go for isolates. Isolates are really good, but it's expensive. It's not very sustainable because you have more and more processing is needed to get them into 90% pure. And you also lose a lot of proteins during the purification steps. I'll teach about this purification and other things in my next lesson. Okay, so protein concentrates are basically used in this what we call cereal grain, I mean what we call breakfast cereals in the morning. You can use that one. And when it comes to isolate, they're extensively used in meat analogs preparations. If you want to get plant-based chicken, plant-based beef, then basically soy protein isolates are used because they are easy to functionalize them. There is a less problem with the taste and other things. About the functional properties of proteins, I'll take an exclusive lecture on functionality in some other days, but I just want to explain that soy protein is one of the most functional proteins. It has a really good solubility, very high solubility compared to any other plant proteins, and it's very functional. It has a very good, this is soy protein isolate. It has a very good water holding capacity, very good oil holding capacity, let's say compared to pea, for example, pea protein isolate. So this one is very comparable. Basically, water holding capacity is much higher. So since it has a very good functional properties, people are extensively using soy protein in a lot of plant-based foods. It could be plant-based meat analogs. It could be breakfast cereal. Soy is extensively used. Coming back to your concept, health benefits, I have been reading so many articles recently, but I could not come up with a solid justification. I can just say that there are some articles that say that if you eat soy-based plant proteins, you can lower the cholesterol, it increases the muscle growth, and prevent cancer. I'm using the word claim. It's not completely proven. It's claimed based on the one or two research articles. So there are some things they show that it has added advantages by going to using the soy-based this one. But the one thing I found a lot of research on this particular thing that if you consume more soy-based products, apparently you can solve the problem with this menopausal symptoms. For example, usually the women get weaker bones at that particular time because they can't uptake calcium a lot, and the soy proteins contains isoflavones, which is a kind of an estrogen kind of molecule, a hormone kind of molecule, and that apparently helps in improving the bone density in women during the menopausal time, right? So that's lot of studies that prove that one. So it is one of the added advantages of consuming more soy-based food during that particular time. So as I said, it's important that who is consuming and to what extent they're consuming plant-based protein is also important to get the benefit. I really want to talk a little bit about the deficiencies or limitations of soy. The first one is it contains little amount of cysteine and methionine. It's also depending on the varieties. So usually most of the plant-based proteins are deficient in methionine and cysteine compared to animal-based proteins. And some plant-based also contains less amount of lysine and tryptophan. Remember, these 4 amino acids is actually limiting amino acids. Cysteine, methionine, lysine, and tryptophan are less in plant-based proteins, not all, in many. So we need to find solve way to solve this problem. Okay. The second thing is soy products also pea proteins also have a grassy flavor. It's because they contain this compound called hexanol, which is a volatile compound, which comes from the lipid oxidation pathway. So because soy is actually oil-containing product, that's right. Pea also contains small amount of oil. So these oily leguminous plants, they contains hexanol because of the oxidation of these fatty acids, and that gives you like a beany flavor, a grassy flavor. And nobody wants to drink a milk which smells like grass. That's the problem. So we need to. There's a lot of research on how do we reduce this grassy flavor by fermentation, by processing, by heat treatment, by germination, by a lot of other techniques you can use to reduce this flavor problem. And then this is the biggest challenge of soy today, that is deforestation and biodiversity loss. Because now we want more and more plant-based, then people will start growing more and more soy. More and more soy means soy needs a lot of land, is causing deforestation. And not only that, it needs biodiversity loss. That means because of soy, they're not able to grow some other crops, or the deforestation directly is linked with the biodiversity loss. That's one of the biggest challenges. For example, there are some articles that clearly show that the soy is not very traceable, because soy is grown in different parts in America and Brazil and Argentina and China. It's very difficult to say how exactly they're growing. And most of the soy that comes from the US, apparently they're genetically modified organisms. If I'm not wrong, now over 90% the soy in the US is genetically modified. It's very difficult to use them in the European continent. For example, the EU laws prohibits using GMOs as food, at least today. They are very strict on that one. So if you do not know how they have grown, what kind of varieties of seeds they have used, then it's very difficult to have a market. And social and economical aspect, as I said, if you want more soy, they start growing more soy and less of other crops. The price of the other crops can increase because now the farmer is growing more soy. So there is actually price effect and economical and social aspects as well. And then the most important thing is soy is not apparently sustainable simply because it requires a lot of water. 1 kilogram of soy production apparently requires 38,950 liters of water. I forgot to put the reference for that one. So it's a lot of water to get soy. So it's not so sustainable because of these two reasons, I would say. The rest can be managed somehow. Okay, and that is the reason why the soy is not, and soy also contains a lot of allergens, lot of allergenic proteins here, and that problem also has to be vanished. I'll take it in detail in next lesson. Okay, and that's the reason why, especially in the European market and also in the maybe in the Asian market, soy is not extensively used, and they are focusing more on P. P is basically they're using LOP at the moment. Usually the LOP is used for the protein production, which belongs to the species called Pisum sativum. There's a lot of research articles at the moment working on P, and they use soy as a reference, as I said. Now it's the time for P at this generation. There's a lot of people working on P and also on fava proteins. It contains a good amount of proteins and fat, so you can have up to 23% of protein on dry seed. Soy also contains mostly globulins, which contains three types of globulins: legumin, vicillin, and convicillin. It also contains albumin, mainly water-soluble albumin like this one. And there's a small amount of prolamine and glutalin. You don't have to remember all these things. Just remember that like soy, P also contains globulins, salt-soluble proteins. I'll just briefly show you the digestibility of pea protein isolates. For example, studies show that its PDCAS value is 93%, is equivalent to 0.93 if you call it as if you truncate it to 1. And casein is milk is 100%, egg is 100%, soy is 100%, and this is 93%. It's not as bad as other, I mean, is equivalently, if good, equivalent to milk and soy proteins. Not super bad. 93% digestibility is okay. Okay, so that's the reason why now soy is replaced by pea. That's also one of the reasons why, because pea can be grown in some other part of the world. For example, EU can grow pea. There is very difficult to grow soy. So it depends upon the regional thing. Please note that one. I'm not telling that we need to grow pea, we need to grow soy, depending upon which country you're situated. Some countries, because of the environment, the climate condition, they can't grow soy. They can grow pea. They can. That's the reason why it varies from country to country and continent to continent. Okay. I don't go in detail, but here also we can see that pea also contains a very good essential amino acid composition, similar to soy. I think it has one problem. What was that? Methionine and was it lysine? I think the methionine is not high in pea, and also lysine is not so high. So that's a two, and cysteine is also very low in pea. So these are the limiting amino acids in pea. So that's the reason why they're working on different varieties of pea now to have more methionine and cysteine content. Okay, please note that methionine and cysteine is not just important on a nutritional point of view, it's also important in the flavor point of view. Because methionine, upon cooking, upon fermentation, upon processing, produces the meaty flavor. Cysteine also gives the meaty flavor because it contains sulfur atoms. They form a lot of sulfur combined volatile compounds, and that is actually gives you very good aroma to the meaty product. And that's the reason why we need to focus more on methionine and cysteine, not just because of the essential amino acid point of view. Okay, they're also important on the flavor point of view because methionine provides meaty flavor in food, especially in meat analogs. Okay. I don't go details in, I mean, please note I have appended a lot of tables. When you're free, just go through it. I don't teach you every single thing, but I only highlight what is important in this table. Now this table shows that about the water holding capacity and oil holding capacity of pea. They're good, they're not super bad. But the important thing what you have to notice here is that, and this is the air classified pea protein. With the air classified will I think have around 40% protein, let's say. Okay, and these are the here it is written 40 to 55% protein, and these are the isolates. You can see it's around 90% protein. Okay, and when compared to the flour or concentrates, the isolates have superior functional properties. Can you see? It has a better oil holding capacity. So that's the reason why sometimes you need to purify your protein to higher degree to get one type of functional property. For example, if you want to use this particular product in, let's say, meat analogs, it's important to have a water holding capacity. For example, meat is always juicy in nature. Do you agree? Chicken, if you go to KFC, we want to eat the juicy chicken. It's not a dry chicken. We don't like it. That should be juiciness, and that juiciness is directly linked to the water holding capacity of let's say plant proteins. Okay, and certain cases we need oil holding capacity. We want to create an emulsion. We want to make an equivalent to butter. If you want to make an equivalent to some other oil rich products, it's important to have the oil holding capacity, right? So depending on the type of the application, we need to use the purified products. Usually it's said that, usually not 100% time, usually highly purified will give you better techno-functional properties. Not always, usually. But high processing compromises the yield and also compromises the sustainability stuff. It's not very sustainable. So gentle processing, less processing is always easy. And this is where we are actually battling in the research field also. How we process less and we get the highest functional property. Okay, that's also a research area, gentle processing. Process less, get the high benefit. How do we do that? Now I'll move on to one of other important oil crop is rapeseed, which is the one of the largest oil seed that is consumed in the EU. So basically, European continent is sea, and Canada and the China is the largest producer of rapeseed. It is like a mustard seed. Have you seen mustard seed? Belong to the same family, mustard family, Brassicaceae, I think, right? And basically, it's an oil crop. You get a rapeseed oil. It's not consumed a lot in India. They do in some part of the Indian state. But if you come to Europe and Canada, basically they use rapeseed oil a lot. Maybe we use a lot of sunflower and palm to an extent. At least in Karnataka, I don't know in Orissa. Do you use? Was that? Yeah, exactly. That's the same thing. Exactly. So, but in Europe, it is one of the important commercial crop to get rapeseed oil. Now, after extracting the oil, how to get the oil is that they take the seed, they crush it, and the oil is removed. Cold pressing, the oil is removed, and then they get this so-called press cake. In India, we give it to cows, right? In India, we give it to cow. Now, I just told in my very first slide, we cannot have more and more cows. Then coming back to your question, who will eat this one now? We have to eat it. Because this is a feed, but this contains about 35% of good quality protein. But it's not just protein, there is 65% other thing is present that animals can digest, we cannot digest properly. So that's where we are holding, because it's produced in a very high volume, especially in Europe, Canada, and China. If you only use oil, the press cake we had to give it to animals, but we don't have enough much animals. We have to reduce animals, but you're getting more and more feed left. So we convert the feed into food by getting the proteins out of them. That's the research. So coming to the rapeseed proteins, it contains two classes of proteins, cruciferin and nepin. Cruciferin is a larger protein and nepin is a smaller protein. I don't go in detail. I'll send the slides to you. Take a read when you're free, but remember that it contains two types of proteins. In our department, we're doing a lot of research on these particular proteins. For example, okay, I'll come back to that one. Let's look into the digestibility of rapeseed protein. Do I have the data exactly? It's 93. Can you see? About 93% is a PDCAS. Casein is 100%. So it's not equivalent to milk, but not super bad. 93%. Okay,
It also has a very good essential amino acids that we need and comparable to soy. Okay, depending on the processing, we can actually change the digestibility. That's the take home message from this slide. Okay, and please note that the processing has a huge impact on digestibility because they change the protein structure, they remove the anti-nutritional factor, a lot of other things they do. So based on that, the digestibility of the protein also varies. All right. As I said, we are in our department, we're working on this particular project. For example, I am leading one of the projects called Seed Food here as a co-applicant. This project is funded by the Novo Nordisk Foundation, one of the largest foundation in the world. And we have received about 56 million Danish krona. 56 million Danish krona is equivalent to maybe around roughly about 65 crore Indian rupees. It's one of the largest projects. I'm just highlighting this because the Danish government is now, the Danish society is putting a huge emphasis on converting animal-based into plant-based, especially valorizing the side streams, because they otherwise feed this one to the pigs. Now pigs, they want to reduce. Somehow we have to eat this one. So that's the reason why they're emphasizing the research on this particular area. And this is one of the largest projects we're running at the moment. The idea in this particular project is that rapeseed protein is, we have 35% protein in that cake, the press cake, but they are not edible. If you eat rapeseed protein, it tastes yuck. It's really bad, I can tell you. So you can't eat, you go and go back to your home and you eat that, you go to your, I mean, it's used as a cow feed, right? You take one small cake and eat it. Don't eat a big one. You feel that bitterness, astringencity. It's really not good, not edible. But we are trying to improve the functionality by isolating the proteins so gently as possible and then use it as in different food products. That's the whole idea of this particular project. What we are doing here is that we are developing new technologies to isolate cruciferin and nepin from the rapeseed proteins, and then we are trying to modify the proteins using different enzymes and chemicals so that it becomes more functional. We can use it as a food ingredients. Then we are also producing that in we're trying to understand their biophysical properties and so on. And then the huge emphasis on the functionality part. How can we improve the flavor? How can we reduce the anti-nutritional content? How we can reduce the astringencity, that the dryness in the mouth after eating this rapeseed proteins. We are doing a lot of research in this particular area. When you know all these things, basically we can create at the end of the day a protein-rich ingredients with cruciferin and with nepin, and that can be incorporated into, let's say, meat analogs, plant-based milk, or infant formula and so on. That can find numerous other application because I can't use the cake into infant formula. Infant can't eat them. But if I can isolate these proteins as pure as possible in a good way, if I reduce all the anti-nutritional compounds, probably I can incorporate them in the infant formula. Just to give an example. So we have to do a lot of things to use plant-based proteins as an ingredient. It's not an easy job. There's a lot of unwanted things associated with them. They always not bring the good functionality. They have a very poor solubility. That's one of the biggest challenges with plant protein. Solubility is always very poor, most of the plant proteins, except soy. Here in this slide, you can see that this is less pure. You can see that the emulsifying capacity is lower, and when it's more pure, it becomes higher. And here also oil holding capacity is also increasing. So why it happens? Because when you have other components present in the food system, you have a protein powder, and let's say 70% is protein and 30% will be carbohydrates and fibers, minerals, anti-nutrients, phytic acids. So many other things will be there in this 30%. The functionality we are aiming is from the proteins, but these are always trying to interact with the protein simultaneously, right? Because they can disturb some of the functional groups on the protein. They are responsible for water holding capacity and oil holding capacity, and they start interacting with the proteins more and more in the food system. So you can compromise their functional properties. So that's the reason why, okay, if you get rid of these unwanted compounds, you can get the functionality that's purely coming from the proteins. It's not always true, because sometimes if you have polyphenols, they call it as anti-nutrients because they give a bitter taste. But when the polyphenols is bound to proteins, the solubility of protein is increased. So it's very difficult to say it's always the bad or not. Sometimes they're good, they improve the solubility. Sometimes they're bad because they changes the taste of the protein. So you need to find the fine balance, and that's where the research is very important. So I cannot make a general statement saying that if you have a 90% protein purity, it's the best one. No, it is best in some part of the technofunctional property, not necessarily in everything. And the next important alternative protein is insects. How many of you have eaten insects? There's a lot of consumer disagreement, disappointment with eating insects. But there are countries, they use insects as food. You go to Thailand, you go to Cambodia, you can find in the street vendors there mealworms and other insect. This is the picture from there, right? They eat it as a snacks and so on. It's very common. But in Asia, some part of Asia, not all, especially in India, and if you come to Europe, Western world, they think insects as yuck thing. We can't eat them because we have this perception that insects are bugs. We have this perception that insects carries disease. Right? It's not necessarily true. I'm telling you. So that's the reason why the consumer acceptance for insects is quite low in the Western world and also in India. But some part of India, they do eat insects. For example, if you have seen mango tree, right? On the mango tree, you get this red color ant. Have you seen? And one day you just pick, they bite also, just pick and then eat them. It's very sour in taste. I did that when I was small because it has a formic acid. You can actually make a very nice chutney out of them. It goes well with dosa apparently. I did not try though, but it's being eaten in some part of Indian culture also, especially those ants. Now, why I'm talking about insects, this is one of the booming market today, eating insects as proteins. If you look into the protein content in the insects, it's very high. It can reach as high as 66, 77%. For example, the bees and wasps, 77% of their body weight is proteins. That's really cool, right? Milk is only 3.5%, beef is 25%, chicken is 21%. You take flies, is 77%. And not only proteins, they also actually have a lot of other ingredients. They have a very high amount of good fatty acids, very high amount of minerals. I'm not exaggerating them. It's really rich when compared to any other food, I would say. Very high amount of high quality protein. This is crickets. If you go to paddy field, you can find them actually. Don't eat raw, but you can fry and eat apparently them. So it contains very good amount of proteins and polyunsaturated fatty acids. Why can't they become an alternative food source? There's another benefit of them using here. Very nice slide, I found it in the internet. To grow, let's say cow, it requires around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, approximately 20,000 liters of water to get 1 kilogram of meat. Okay, around 10 kilos of food, around 250 square meter of land you need. Highly demanding. Plus, only 40% of cow is edible if you take beef, because the rest is bone, head, hair, and skin, and so on. They're not edible. In chicken, 55% is only edible, the rest is you have to throw. But if you take mealworm, 80% of mealworm is edible, apparently. So, by weight, they are actually highly sustainable. Plus, they only requires 1/10 of what you need, the resources, if you say animal based. Very less resource consuming, high amount of protein, whole body part is edible. Why can't we use them? If you look into the carbon footprint, insect has an extremely low carbon footprint compared to animal based. They're actually tick marking everything. The problem is consumer acceptability, which is way lower. It's simply because of our tradition. But the insect market is raising 20% every year in the European and the American market, apparently. It's because of the ingredients. I'll come back to the later. And it also has a very good essential amino acid score. Even better than, let's say, beef in some cases. Even better than chicken in some cases. Really good amount of essential amino acids. And their digestibility can also reach as high as 90%, 95%. It's very digestible if you take the protein from them. And if you compare to casein, They're equivalent, right? So insect could be a potential alternative protein source for the future. The challenge, as I said, consumer acceptance. Many people don't want to eat insect as a whole. However, there's a lot of consumer survey. They clearly show that it's very difficult to eat them like this in this particular form. But if you convert them into ingredients using processing, then apparently they don't care. You convert insect into insect flour or insect protein isolate. Now it's just a protein, and that can be incorporated in your pasta or in breakfast cereals or meat analogs, and that can be used as a food. And that's a market. That's a growing market in this particular direction, not necessarily eating the whole insects. Does that make sense? And here we food scientists come into play. The processing has become super important. So insect is a very sustainable source of protein, high quality protein, digestible protein. That's a poor consumer acceptability in certain part of the world. However, if you convert them into ingredients, there is a high consumer acceptability. Yeah. And then the other thing is called myalgae, and you must have seen these two pictures in your daily life, right? You just walk inside the villages, you find the pond, it looks green. They're nothing but algae. And the algae, and then in the sea, you can also find seaweeds. If you go to beach, you'll find these things are floating. They're also a good source of proteins. Microalgae is something you find it in the water. They are photosynthetic organisms. They just want light and carbon dioxide and some organic matter, and they grow readily and they accumulate a lot of proteins. The protein is one of the most important ingredient they produce in their cells, microalgae. As high as something can produce accumulate as high as 70% of their biomass as proteins. That's really high. And they can be grown in very small piece of land, because to grow soy, for example, you have to grow them on the land. Microalgae can be grown on photobioreactors, one over another, one over another, one over another. That means you don't need much space. You get equivalent amount of proteins. And they need water, but the water can be reused. But usually agriculture is very difficult to reuse the water because it goes to the soil. But here it is in the reactors, the water can be reused, so it becomes super sustainable. Does that make sense? So microalgae is one of the most important source of protein. Not only protein, they produce all other good ingredients that we need. Here is a slide that shows that this is spirulina. You have heard about spirulina, I think. It's also used in India. I have seen many research Indian scientists are working on spirulina. It can accumulate up to 70% of protein. And if you compare to vegetables, your 5%, it's your 70%, very high amount of protein. And the protein quality is also really good. It's very equivalent to eggs and soybean, to be frank. So it produces high quality proteins. And I think you can buy these spirulina tablets and powders not in the supermarket, but in specialty stores. They sell as a food supplement, because they have good amount of protein and good amount of fat, especially PUFAs, polyunsaturated fatty acids. I'll just show you, we are doing a lot of research in our department on cultivation of microalgae. They can be cultivated on conical flask, or you can buy them the photobioreactors, and you can also grow in the large reactors like this one, and also as an open pond. So if you cultivate in this large photobioreactors, you can actually save a lot of space. In low amount, in minimal space, you can get more amount of protein. That's one of the advantages of microalgae. These are some pictures, the helicopter view of how the microalgae is cultivated in USA, for example. Large area they're doing is open pond cultivation. Seaweed is also grown. I think it's in some part of seaweed is also containing protein, but not of 70%, but they're actually having around 10 to 15% of protein, not very high in protein. But they can also grown in sea, especially in Tamil Nadu, they're growing seaweeds, but not for proteins. They're growing it for the carbohydrates, because they produce sulfated polysaccharides. Is also used as a gelling and thickening agents in food that can be sold to 60 to 70 rupees per kilogram. So there's a big business on seaweed cultivation. But the biggest challenge is today the microalgae is still expensive. It's not so cheap, simply because the photobioreactors that you need It's not cheap. And some of the nutrients we still supply, they grow on light and water, but you still have to supply nitrogen sources that become super expensive. They are approximately 10 times expensive at the moment, some of the microalgal biomass. So where you have to use biotechnology to improve the yield, the biomass growth and so on, we're also working in our laboratory to improve the microalgal biomass growth.